Hi everyone, I'm Zheng Haohe from the University of Virginia. Today I will introduce GCAV, a framework that improves the consistency of concept-based interpretability across different layers of deep networks. Our work builds upon TCAV, but solves one of its core weaknesses, its instability across layers. First is our motivation. Traditional TCAV computes concept activation vector casts independently for each layer. As a result, the same concept may look strong in one layer but weak in another, making interpretation unstable and hard to trust. This happens because each layer encodes information at different abstraction levels, textures, shapes, or semantics. Our motivation is simple. Instead of treating layers separately, can we create a single global representation that stays semantically consistent across the entire network? That's what GCAV does. Let me introduce our method. GCAV has three key steps. First, we train layer-specific autoencoders to unify the dimensionality of CAVs. Second, we use contrastive learning to align concept representations across layers. Finally, an attention-based fusion module integrates all aligned CAVs into a single global concept vector. This unified representation allows us to apply testing with GCAV, projecting the global vector back into each layer to get consistent interpretable concept scores. GCAV is calculated using following formula. We test GCAV on multi-CNN architectures, GoogleNet, ResNet v2, and MobileNet v2. We compare two CAV. Our method significantly reduces score variance across layers and ensures consistent concept importance. In other words, no more guessing which layer is right to interpret. The quantitative results show a clear drop in standard deviation and range ratio of concept score, confirming cross-layer stability. When we visualize concept maps, the improvement is obvious. Original TCAV often highlights irrelevant background regions. In contrast, GCAV produces sharper and more focused maps, precisely matching the true concept locations. We also test robustness by applying adversarial perturbations in a single layer. While TCAV interpretation collapse, GCAV remains stable because it aggregates information across layers. This demonstrates both semantic precision and robustness. To summarize, GCAV builds a global cross-layer consistent concept representation, reducing variance, improving localization, and enhancing robustness. We believe this work offers a more stable foundation for concept-based interpretability in deep models. Thank you for listening, and I'm happy to take questions.